Welcome to AP Statistics. In this video, we're going to talk about how to describe quantitative data. So first, we got to talk about what quantitative data is. Remember, quantitative data is data that can be counted or measured in numerical values. So if your data comes in the form of numbers, and those numbers were either from counting, like, hey, I counted 16 red Skittles, or they came from measuring something, like, oh, I measured that person, they weighed 146 pounds. That's quantitative data. There are two main types, discrete and continuous. A discrete is where you think about the variable and you think, okay, I can make a list of all possible outcomes. So for example, how many goals could Jake score in a soccer game? I can make a list of that. 0, 1, 2, 3, 4, 5. Like, he's never going to score more than 5 goals. He's played soccer for 100 years and this is never going to happen, right? But again, that would be discrete. Typically, we're thinking whole numbers here, but the idea is that you could actually make a list of everything that's possible. Whereas continuous, all possible values are technically infinite. This is where we start thinking about decimal places. Like if I'm going to say, all right, the height of a tree. Well, boy, the height of a tree, if you go to a second, or even if you go to a first, second, third decimal place, now the possible values that a height of a tree could be is pretty infinite. I couldn't make a list. Okay, 10 feet, 10.1 feet, 10.2 feet, 10.22 feet, 10.23 feet. Like, the list becomes infinite when we start thinking about all the different values that that measured variable can take on. So those are two different types of quantitative data. Hopefully remember that. Now, one thing we want to do is make a graph. Like, graphs are awesome. They're great ways to organize the data so we can really, truly understand it. There's all different types of graphs we'll talk about in one moment, but all graphs have something really important in common. You need a number line, right? You need to get your data, and you need to put your data in order, and you need to create a number line, and all of your data goes on that number line somewhere. So, where does your number line begin? Where does it end? Well, you want to kind of think about the min and the max of your set of data. And then you could find all different kinds of ways that we're going to talk about in later videos to actually make a graph of that data, but they all have a number line in common because your data, whether it be discrete or continuous, is going to fall in a number line. Now, when you create that number line, you want to pick an interval size. Like, do I want to go by 5s, 80, 85, 90, 95? Or do I want to go by 2s? Do I want to go by 3s? Do I want to go by 0.5s? It all depends on your data. You don't want too many intervals, but you also don't want too few intervals. So you got to think about your min and your max. You got to think about, okay, if I want to get from my min to my max, how do I want to separate that up to have some nice intervals throughout? And I know that may be a little bit weird without actually showing you an example right now, but you're going to see tons of examples as we analyze graphs. Now, here are the different ways that we can actually make a graph of quantitative data. Dot plots, stem and leaf plots, histograms, box plots, and good old cumulative relative frequency graphs, also known as ogives. Now, all are great. They're all great in their own way. I'm not going to sit here and say that one of these graphs is better than another. Not one graph is the same as the other either. They're all different. Okay? Now, there are situations where it makes more sense to maybe use one type of graph versus another, but they're all very great graphs and they all show the key characteristics. When you look at your quantitative data in a graph, you want to see the distribution. The distribution is what values your data takes on and how often it takes them on. So I want to be able to see that in my graph. Oh, I see the data ranges from 80 to 110, but there's a majority of data built up around 90, right? I want to be able to see that distribution, and all these graphs is going to allow you to see that. Again, the distribution of your data is really important. That's the main idea, right? Regardless of what graph you're using, all three aim to show the distribution of the data. I don't know why I wrote 3 there. I think I just showed 5. So all 5 of the graphs aim to show the distribution of your data. Again, I can't emphasize enough what distribution is. It is what values the variable takes on and how often the variable takes those on. So I want to be able to see the spread of my data, small to high, and I want to be able to see where the majority of my data falls. And again, all the different types of graphs are going to help me see that. Now, anytime you examine, anytime you're asked, hey, describe what you see in that distribution. Oh my gosh, that question is going to come up on quizzes, tests, and it's going to come up on the AP test. You need to talk about 3 things, maybe 4. The shape of the distribution, the center of the distribution, and the spread of the distribution. All right. Center's really easy. We're going to start there first. You're just using your eyeballs. What's one value that looks to be in the middle? Later on, we're going to talk about words like median and average and mean and all that fun stuff. Don't worry about that at this moment. Just worrying about using your eyeballs and saying, oh, the center of the graph looks to be around 85. You're just looking for one value that you think kind of splits the data nicely in half. All right, spread, that's pretty simple. We're just talking about, hey, the data spreads really far. It goes from 80 all the way to 1,000. Oh my God, that's a huge spread. Whereas a small spread would be 80 to 85. So again, you need to look at the distribution. You need to look at the graph to see how your data is spread out. I kind of think about it like putting butter on my toast, right? Do I just put one big clump in the middle where it's not very spread out, or do I evenly spread it out from the beginning, the left, all the way to the right? Now, outliers is also pretty simple to understand as well. We're going to talk more formally about how to identify outliers, but at the end of the day, an outlier is one value that's really far away from the rest of your data. Now, the last thing is the shape. This is a little bit weird, right? We have a couple really common shapes. We have symmetric. If you put a line right down through the middle, you could fold it and they're kind of same. You could be symmetric like this as well. I know these are terrible pictures, by the way. But again, put a line down through the middle, fold it, they're going to be very same. We also see skewed left and skewed right, very common ways to talk about shape. So skewed, let's talk about skewed right first. That is when the majority of your data is on the left, less data is to the right. So most data is towards the lower values, very little data to the high values. And again, this is not symmetric, because symmetric is your data is all chunked in the middle, a little bit on the left, and a little bit on the right. But if you have a bunch of your data on the left, a little bit on the right, that's what we call that skewed right. Skewed left is the opposite, where we see only a little bit of the data on the left, big chunk of the data on the right. So think about skewed left, skewed right. Got to kind of have to memorize those terms. But again, I think about my feet actually. If you think about your left foot, your toes are skewed left. The bigger toe is on the right, the smaller toes are on the left. So less data on the left, most data on the right. That's skewed left. Skewed right is like your right foot, bigger toes on the left. So most data is to the left, less data is to the right. So when you look at a distribution, you want to make sure you talk about those three and outliers. You're not always going to have an outlier, so there's no outlier, no need to mention it. Or maybe you could just mention that there are no outliers. But you got to talk about shape, sun, and spread for sure when you're analyzing your data. All right, that's it. Stay tuned for the next couple of videos because they're going to talk about the different types of graphs.